Okay. So when you do curl, when you have to find the curl of a vector field, your job is to put I, j, k across the top of your block. You're about to compute a cross product. Then you put partial x, partial y, partial z. Okay? These are going to be some partial derivatives to compute. And then in the bottom row, you put the vector field. So what's your vector field? So Brandon, give me your vector field.
My vector field, 2zx.
Okay.
And then xy.
Okay.
And then 3yz.
3yz. Okay. So as always with any cross product, we start with I times open parentheses minus j times open parentheses plus k times open parentheses, right?
Yeah.
Yes? Okay.
Yeah.
When you go to compute this 2 by 2 determinant, you say partial derivative of 3yz with respect to y. So what is the partial derivative of 3yz with respect to y?
3z.
3z, good. Then you say minus the partial derivative of this guy, the xy, with respect to z. What's the partial derivative of xy with respect to z?
0.
Yes, 0. Good. Hold on. I'm going to fix the focus a little bit. Minus 0. Good. Okay, the minus j, we move over to j. Now we do this 2 by 2 determinant. The partial x times 3yz minus partial z of 2zx. What's partial x of 3yz?
0.
0, yay. Partial z of 2zx?
2x.
2x. We're going to say minus 2x there. Good. And then lastly, we have the k determinant to do, or the k part of the mini determinant. Partial x of xy, that's y. Partial z of 2zx, that would be 2x. So we have y minus 2x. Wait, no, I'm an idiot. Sorry, partial y of 2zx, that would just be, Logan, what's your q? That's your q?
Wait, hold on.
0.
0. Good.
Is that our answer?
So you could say either 3zi plus 2xj plus yk, or you can put it in vector angle bracket notation like this, which is what I tend to like to do, but that's it. Yeah, either way, either one is your curl. Good?
Yeah, let me submit that answer real quick.
Number 2.
Guess what? It's the same thing. Do you want to do it again?
Nah.
Okay.
Let's do
3, divergence. Divergence is actually easier. So the divergence of a vector field is partial derivative of the, we'll say, let's do this. Let's say your vector field is P, Q, R. So the first component is P, the second component is Q, and the third component is R. Then the divergence of a vector field is partial P partial X plus partial Q partial Y plus partial R partial Z. You just take the derivative of each component with respect to the variable that component corresponds to, and then add them all up. So what's your vector field, Logan?
3x squared yz I plus 2xy squared z
Okay.
minus xyz squared.
Cool. Okay, what's the partial derivative of your first component with respect to x?
yz.
6xyz, yeah. Partial derivative of your second component with respect to y?
4xyz.
Very good. And the partial derivative of your third component with respect to z?
Negative 2xyz.
Which all boils down to become 8xyz. Divergence is a lot quicker, right? I don't have to do this crazy ass determinant computation that I had to do for curl.
Wait, I'm sorry, say that again. I broke up.
That computation is a lot faster than the curl computation,
Yeah,
right? What did I have to do in order to do the cross product? I had to do spoiler alert. What did I have to do to get my curl? I had to do a what?
Cross product.
Cross product. Did I have to do one here for the divergence?
No, you just took straight up partial derivatives.
And then add them all at the end, right?
Yeah.
Okay.
Is 4 the exact same and 5?
4 is the same, 5 is the same. Just bear in mind, you're going to have to do some sort of product rule, I'm sure, at some point, right?
Sounds like Wolfram to me, but sure.
Yeah, I don't know if it can. Maybe Wolfram Alpha can handle a divergence, but yeah. Oh, you mean just taking the partial derivative? Sure, yeah.
Yes.
The identity curl of v cross x equals 2v holds for all vectors when v equals abc and x equals xyz. I'm inclined to think that it's false, but we can find out ourselves. So we want to find the curl of v cross x. Let's go ahead and find v cross x. I need to erase this.
Is this the blackboard thing or the whiteboard, the clear board thing that you set up in your?
Yeah. Okay. Let's first, so they want us to find curl of v cross x. Well, let's first find out what v cross x is. Recall, it also
We're on
has-
number 6, right?
What's up? Yeah,
Yes.
6. V is the vector a, b, c. And x is the vector x, y, z. What is the cross product v cross x? Well, I'm going to put ijk across the top. This is going to give me I times bz minus, bz minus cy plus, rather minus, j times az minus cx plus k times ay minus bx. How did I get that? What do you guys see inside the curl part of the part that says curl? It says curl of what? Curl of
V cross X,
v cross x. They gave me the vector v. They told me v was what?
ABC,
They told me, and then they said x was what?
XYZ.
Cool. I just took the cross product of those two vectors. ABC cross with XYZ gives me this. And now I'm asked to find the what of that. On the outside of that cross product, it says what? Compute the what of that.
Huh?
Brandon,
2x.
it's asking. So that is just v cross x. What is this inside of? It's inside of a what?
Curl.
Curl. It wants you to compute the curl of this result. So we have to do yet another cross product, ijk. What's the second row in a curl computation?
Partial X.
Partial x, partial y, partial z. Good. And then the p, q, and r components go on the bottom. Those components are bz minus cy. It's a mess here. I'm going to try and write small. Bz minus cy. I'm going to distribute the negative here to the right to give me cx minus az. And then I have ay minus bx. Okay? Once again, I'm going to say I times open parentheses minus j times open parentheses plus k times open parentheses. Let's start with the I parentheses. We have partial y of ay minus bx. What does that give me? What's the partial derivative of ay with respect to y?
A.
A. And the partial derivative of bx with respect to y?
0.
0. Minus the partial derivative of cx minus az with respect to z. What's the partial derivative of cx with respect to z?
0
And the partial derivative of negative az with respect to z?
minus z, so it's a plus z.
No. Minus what? You're taking the
Minus
partial.
Minus,
Minus
minus a, so it's.
So it's a minus a there. This looks promising, by the way, because the whole result is supposed to be 2 times v, right? So we have 2ai, 2a, and then we want the partial derivative of, and we do this guy, partial x of this, so that would be negative b, minus partial this of z. The partial derivative of that guy with respect to z would be b. We do minus b because it's the second term. And then plus k times, now we're doing this 2 by 2. Partial x of cx minus az would just be c. Partial y of bz minus cy, that'd be negative c. So we end up with 2a. We have minus negative 2b, that just becomes plus 2b. And we have plus k times c plus c, which ends up being comma 2c. So we end up with 2a, 2b, 2c. Is that equal to twice v?
Yes,
Yes. So is this true or false?
true.
Seems true to me. Check it. Gotta hope I'm right.
Dude.
Nice try.
Next homework.
All right. Now we're doing some double integrals.
No, now you're doing some.
Wait, what?
What?
I
what
just put true and it's wrong.
What?
Hold
Okay.
on.
Brandon, is yours the same function?
Well, mine says
Does it say something
equals
different? than what-
2x, so it's false. Shit.
Oh, gee. Maybe you should make close attention to your answer key. Right? I did it for Logan.
Oh man, we only had one shot at that.
It's a true or false question. Of course, you'll get
Yeah.
one shot.
All right, next.
But let's read a little closer next time, okay, buddy?
All right, 5.1 and 5.2.
Are you able to just look
Good
at
question.
the pictures and tell us the answers?
This one I could probably look at and try to tell you the answer. I think the first one's either 15 or 17.
Should I just guess one of those right off the bat right now?
You could probably guess. If I were to guess, I would guess 15, but I'm not sure.
1 plus x squared minus y squared on the integral of -2 to 2 for x and -1 to
Yeah,
1.
I know. I see the problem as well. Okay. So we're doing this double integral. We're doing the double integral of what function? Yours is 1 plus x squared minus y squared. The nice thing about this double integral is that the bounds are constant. So guess what? You can choose whatever order you want. You can do x first, then you can do y first. You can do y first, then x. Sorry. You do x first, then y second, or y first, then x second. So it doesn't really matter because, again, the bounds are what?
-2 to 2.
No, the bounds are what? Why can I do whatever order I want? Because the bounds are, okay, I guess you guys missed it when I said it. The bounds are constant here. The bounds on x go from one constant to another constant. Sometimes the bounds will be constants. We might see that in the next homework that they're not constant. So we can't just switch the order willy-nilly. We can switch the order willy-nilly because the bounds are
Constant.
constant. So what order would you like to do? dy dx or dx dy?
ui dx.
ui dx. Now, some of you watching may have had Professor Davis for Calc 2, which means you don't know how to do double integrals. Or maybe you do, but you probably forgot, but she was not a very good teacher. I'm going on the record as saying she's not really good at teaching you how to do double integrals. So this is going to be maybe new for you, or maybe it seems familiar, but you didn't practice a lot because you had Professor Davis. Brandon, you had Professor Starin, so I think you got some practice with this, but it's also been a while. It's just been a while for you guys since Calc 2 anyway, so I'll have to get a refresher here. So we're doing dy first. What are your bounds on y, Logan? -1 to 1, right?
Y -1 to 1, yes.
So those are your innermost bounds. They go there, okay? And then your bounds on x, they go from -2 to 2. So those go there. Now you integrate this guy with respect to y. When do you integrate this? Because the first differential on the inside here is dy. When do you integrate this with respect to y? What do you get? What's the integral of 1?
Y.
Y. What's the integral of x squared with respect to y?
Yx squared.
Yx squared. What's the integral of -y squared with respect to y?
Minus y cubed over 3.
Very good. We're going to plug in 1, plug in -1, and find the difference. This is going to give me 1 plus x squared minus 1/3 minus what I get when I plug in -1. That would be -1 minus x squared plus 1/3, which ends up being 2 minus 2/3 is 4/3 plus 2x squared. Is that good so far?
4/3 plus 2x squared, that's what I got.
Okay. Now we're going to integrate that from where to where?
-2 to 2.
Very good. When I integrate this, I get 4/3 x plus 2x cubed over 3. I'm going to plug in 2, -2, and find the difference. When I plug in 2, I get 8/3 plus 16/3. And then minus -8/3 minus 16/3 for an answer, I think, of 16. Yeah. No. Yes. Good?
I'm trusting you on that one, sure.
Well, there's also a Wolfram Alpha double integral calculator, so you can use that as well.
I'm just going to, let's see. Yeah, 16. Cool.
Yeah, I'm just gonna have to do
Did
this.
we really not do that in Davis?
Yeah, this is pretty easy.
Yeah, I know.
Wait, why did, I feel like we definitely did this in Davis.
You did, but you didn't do it like sufficiently to do. I mean, like you could do this a little bit. I don't know. I feel like
Hey, I was spitting out those integrals to you, no problem.
that's true. I'll give you credit for that. I'm surprised that you didn't screw anything up there. I'm floored.
I'm fucking floored.
Okay, so the next one is very similar. Do you want to do that one, or do you want to skip to the next homework?
Let's just do it while we're here.
Is it different or is it?
No, not different. I mean, there's bounds. The bounds are still what?
Constant.
Constant. So we can do whatever order you want to. What order would you like to do?
No, it's the exact same. All right, let's do the next homework.
Well, no, it's good for me, Brandon, because he just does it for me.
Oh no! I'm not just doing it for you.
Yeah, all right, next
want
one.
If you want to, you can do it yourself, or there's a Wolfram Alpha.
Yeah,
double
I'm
integral.
kidding. I'm kidding. All right. Evaluate the double integral.
Okay. Now this time the bounds are what?
Are we doing it?
We're doing the next one. Next homework.
Oh, next homework. Okay.
So you guys
5.3.
Yep.
They're not constant.
The bounds are not constant, so the order matters here. Generally speaking, your outermost bounds have to be constant. Your innermost bounds can be variables, but your outermost bounds must be constant. With that in mind, what order should we do? Well, whose bounds are not constant?
What do you
Whose
mean?
bounds are not constant? Don't hurt yourself now, guys. Whose bound? What's up? Yeah,
Mine.
Y's
Both
bounds.
of ours.
Y's bounds are not constant. So with that in mind, we have to integrate first with respect to y. Now, I'll grant you, we could probably rearrange the order of integration. That's probably going to be next time, or she might have to on the test, but we'll see what we'll practice with regards to switching the order of integration. But for now, we're just going to say, hey, look, the bounds on y are not constant, so we're going to integrate with respect to y first. We're going to say dy dx. The bounds on y go from 0 to root x. The bounds on x go from 2 to 3. Do you have a similar looking function or integral, Brandon?
Everything except for 1 to 6 instead of 2 to 3.
Gotcha. Oh, and then our integral is 5y over x squared plus 1.
Mine is just y over x squared plus 1.
Okay. What's the integral of this guy with respect to y? Well, the x squared plus 1 we're going to treat as a constant. We can ignore it. What's the integral of 5y?
5y squared over 2.
Good. So we'll say 5 halves times y squared over x squared plus 1. We're going to evaluate this from 0 to square root of x. So that means plug in square root of x for y, plug in 0 for y, and then find the difference. When I plug in square root of x in for y, what do I get?
5 halves x over x squared plus 1.
Good. And then minus what I get when I plug in 0. But when I plug in 0, I get 0. So now I'm staring down the barrel of 5 halves times x over x squared plus 1. I'm going to integrate. We'll put the 5 halves out in front. X over x squared plus 1 dx, evaluated from 2 to 3. A couple of integrals I'm going to give you guys just to have on the top of your heads because you need to know them. You probably forgot about these from a long time ago, but here they are. You must memorize these. Let's change this to an a squared. Damn. And then integral of 1 over x squared plus a squared. Does anyone know this one?
Good
You
one.
guys have a chance to impress me. Good job. I have no expectations for you guys, and you still let me down. Okay. 1 over a arctan x over a. You got that one down?
You really expected us to remember that?
Yep, I did. Okay. So this one, x over x squared plus 1, is not the second integral. It's the first integral, x over x squared plus a squared. So we're going to get 5/4 ln of x squared plus 1, evaluated from 2 to 3. So it's going to be 5/4 ln of 10. You can put parentheses now, we don't need absolute value bars, minus 5/4 ln of 5. Now you might not see this as an answer because Quest is weird, right? Quest always does something to the answer to make it annoying for us. When you subtract two logs of the same base, what do you do with their arguments?
You
Wow.
set up the arguments?
When you subtract two logs of the same base, what do you do with their arguments?
Divide.
There you go. So I get 5/4 ln of.
2.
That's your answer. Is that good?
5.
Wait, where'd you get the 5 over 4 ln 10 minus 5 over 4 ln 5?
Uh-huh.
So mine would be 1/4 ln 10 minus 1/4
Why
ln.
10? Your bounds aren't 2 to 3, homie. You
What?
told me yourself your bounds were 1 to 6, right?
Oh yeah.
So why are you using the same bounds as Logan? Right?
Yeah. Wait, so what would mine be?
Well, what's your upper bound?
1 to 6?
So what's your upper bound?
6?
What's 6 squared?
36?
Plus 1 is?
Wait, where do I plug this in?
What do you think? I think
Oh, wait, I skipped a step. That's why. Okay, never mind. I'll figure it out.
Good job, buddy. You can take a picture of this if you want.
Yeah.
Okay, Logan, was that your answer?
Yes.
Okay, cool. We're going to do the next problem. Last problem.
Woo!
Last problem's the hardest one. I don't know what the setup for the. I don't even know if I'll even do a final exam review now, just because times are weird. If you're watching at home and you do want to do a final exam review, let me know in the comments. By comments, I mean, I guess let me know in the group me, I guess, because that's the only place I'm communicating with most people. But yeah, I want to do a final exam review for this. Whether it's set up like this or whether I have a doc cam, which is probably what I'm going to do. Probably get a doc cam. That way it looks. I don't have to keep erasing the whiteboard or the light board because it's going to be annoying to keep erasing it. So, all right, last problem.
Andy, this is pretty good though.
Yeah, hopefully the production value is up there. Plus, let me look at this face. Yeah, I would like to not have to erase the board every single time I do a problem, you know. Number 2, find the volume of a solid in the first octant bounded by the cylinders x squared plus y squared equals 4, y squared plus z squared equals 4, and it says the first octant. First octant just means x is greater than 0, y is greater than 0, z is greater than 0. So our lower bounds for x, y, and z are probably going to be 0 when we do this double integral. Also, when they want you to find volume, volume is equal to the double integral of z, dA. We usually like to say the double integral of z. Now, technically, you could choose a different orientation. You could say I'm going to integrate the double integral of y, and then my differentials will be dx and dz. But it's just easier to think of. We're going to do the double integral of z and put everything in terms of x and y. That's what we usually do for these double integrals. So the first equation we're given is x squared plus y squared equals 4. Does this contain z at all, guys?
No.
No. So this is not the thing we're going to integrate. This is the thing. This is the region we're going to integrate over. The second equation, however, says y squared plus z squared equals 4. Right? Does this contain z?
Yes.
Mhm.
Yes. So I want you to solve for z in this equation. What would I do to solve for z?
Put the y squared on the other side and square root it all.
Okay. And technically, when you do that, you get z equals what? If you say just square root of 4 minus y squared, I'm going to yell at you. Technically, you're supposed to have a what in front of that?
Plus minus.
Plus or minus.
Right? However, what did we already say about the region in question? It's sitting in the what?
First quadrant.
First octant. First quadrant, sure. First octant, what you meant to say. Where x is positive, y is positive, z is positive. So that means we don't actually really need the plus or minus because we only want the plus side anyway. Does that make sense?
Yes.
Okay, so we're going to do the double integral of this, double integral of square root of 4 minus y squared. And I'm going to be very particular about the order in which I do. I could do, let's just say this, I could do dy dx, or I could do dx dy. If I asked you guys to integrate this guy with respect to y, do you think you'd have a fun time doing it? Well, at least not with the way I phrased that question, right? Do you think you'd have a fun time doing the integral of the square root of 4 minus y squared?
No.
It would require something called a trig sub, which you probably haven't thought of in a long time. And by the way, for what it's worth, your professor and most professors in vector calculus don't make you do some crazy ass integrals, at least in terms of integration techniques you learned way back in Calc 2, like partial fraction decomposition, trig substitution. You might see a U sub, you might see some integration by parts, but for the most part, they're not that common, right? Like it's pretty basic integration, which is a relief to you guys, I'm sure. With that in mind, we don't want to do dy dx because it's going to force us to do a trig sub, and we haven't thought about trig sub in a long time. We'd rather do what order of integration?
dx dy.
Dx dy. And if I asked you to integrate this guy with respect to x, that'd be pretty easy, because what's the integral of this guy with respect to x?
X times that.
X times that, right? So we are going to do the order dx dy. But now we got to figure out the bounds. So this guy is what shape?
Circle.
Circle. Circle of radius 2, center of the origin. Very good. And once more, we're only existing in the first octant, so that really is, as a subset of that, the first quadrant is what we're going to be looking at. Here's how we determine our bounds for y. Our bounds for x, I should say. Ready? As we draw a line parallel to the, which axis?
X.
X-axis. The first thing we hit when we enter the region is what? This doesn't count, by the way, because this is not shaded. What do we hit first? We hit x equals what?
0.
0. That's our lower bound for x. As we continue through the region, what do we hit on the way out? We hit the right edge of the circle. What is the equation of this right semicircle? How could you find the equation of the semicircle? Well, this one you probably do remember from Davis, Logan, is that you probably talked about the 4 different semicircles you could get. The top semicircle is y equals the square root of, you can say 1 minus x squared because that's what Davis did. She always did a radius 1, but we're going to do radius 2 here. So 4 minus x squared. The bottom semicircle would be y equals negative square root of 4 minus x squared. Neither of these are useful to us because we're not looking at the top semicircle or the bottom semicircle. We're looking at left versus right semicircle because we're traversing with respect to x. So that would be x equals square root of 4 minus y squared. That is your right semicircle. And then your left semicircle is x equals the square root of, or negative square root of 4 minus y squared. So when we draw a line through the region, what do we hit first when we enter? We hit x equals what?
0.
0.
Sorry.
What do we hit when we leave?
Square root of 4 minus y squared.
We hit this guy. Good. We hit square root of 4 minus y squared. So we're going to put this as our upper bound. The nice thing about the outermost bounds, as I've said before, the outermost bounds are always what? Outermost bounds are always constants. What is the lowest value for y?
0.
0. What's the highest value for y?
Square root of 4 minus x.
Nope. The outermost bounds are always what?
Oh, constant. So it's 2 or 4.
2. The
4.
highest possible.
2.
Nope. It's 2.
2.
Highest possible value is for y is 2 because there's a circle of radius what? Radius 2, right?
Yep.
So this is the integral set up in its entirety, and now all we have to do is perform it. As you guys said, the integral of square root of 4 minus y squared with respect to x would just be x times that thing. So x times the square root of 4 minus y squared. Our upper bound, we plug in our upper bound, our lower bound, find the difference. This is going to give me, the nice thing about plugging in the square root of 4 minus y squared in for x is that it gives me what? Square root of 4 minus y squared times square root of 4 minus y squared, which is just what?
4 minus y squared.
4 minus y squared. Minus what I get when I plug in 0. But when I plug in 0, I get 0. So now I need to integrate this guy. Now I'm integrating 4 minus y squared with respect to what with respect to y from over what bounds?
0
to 2. This gives me 4y minus y cubed over 3. Plug in 2, plug in 0, find the difference, you're going to get 16 thirds. And that is your final answer. We're good on that?
Yep.
Yeet.
Is there anything else you guys want to do?
Yeah, you want to pause or finish the recording?
Yeah, I'll just pause the recording so we can talk. Actually, well, I'll tell you what. I mean, there might be people who are watching this who might care about what you're about to say, but maybe they don't.
No,
right?
they aren't going to care about what I'm about to say.
They aren't?
No.
They are not going to like what I'm about to say.
They're not going to want to fucking hear this.